Okay, so this is a little consolidation and revision session about logs. So I'm going to talk through everything that you need to know about logs and also some of the big mistakes that people make with logs. Okay, so first of all, what is a log? If you think about the equation x to the 6 is 4 that you probably learned, I don't know, in year 8 or 9 or 10 or something, then you learnt that what you have to do to get your x out of this situation where it's been raised to the power of 6 is to do the opposite of to the power of 6. And the opposite of to the power of 6 is a symbol that looks like this, and it's called the 6th root. So you apply that to both sides of the equation and that releases your x. Well, a log is exactly the same principle, but instead of solving x to the power of 6, you're solving 6 to the power of x is 4. So you haven't got to the power of 6, you've got 6 to the power of. And the opposite of that, if you want to release your x from that situation, the opposite is a symbol written like this, log to base 6. And we apply that to 4. So we've applied it to both sides of the equation. On this side it's just released the x, and on that side you can see it. Just like here, I've done the 6th root to both sides of the equation, and on this side it's released the x, and on this side you can see it. So similarly, we could think about the same thing the other way round. If we had something like the 7th root of x is 2, and we wanted to get the x back, and we wanted to undo that 7th root, then we do the opposite of the 7th root, which is to the power of 7. So that's how we'd solve that equation. If, on the other hand, we had log to base 7 of x is 2, and we wanted to release x from that equation, then we do the opposite of log to base 7. And the opposite of log to base 7, to get rid of this function here acting on the x, is 7 to the power of. 7 to the power of applied to 2, so 7 to the power of 2. So that's a definition. So this is just a symbol meaning the opposite of this, and this is just a symbol meaning the opposite of this, just like this is a symbol meaning the opposite of this, and this is a symbol here meaning the opposite of this. So if you can remember that what a log to base 7 actually means, it means the opposite, the inverse function of 7 to the power of, then that will help you when you're manipulating logs. A couple of useful things that you can remember when you're dealing with logs. Log to base a of 1 is always 0, it doesn't matter what the base is. So that's similar to having a to the power of 1 is always a, doesn't matter what that a is. And also you've got the very useful thing, log to base a of a is always 1, which is the same as that one. In fact, that's what I should have written there. That one is the same as this one, and this one is the same as this one. So log to base a of 1 is always 0. Sorry about that. This is similar to a to the power of 0 is always 1, and the index rule. And here you've got log to base a of a is always 1. So log to base 10 of 10, log to base 7 of 7, log to base 6 of 6, whatever, it's always 1, which is similar to this rule here from indices. So this is a basic definition of what a log is, and these are a couple of useful things to remember similar to your index rules from GCSE. So what laws have we got? There's only 3. This one that you can remember quite easily. It's similar to the index rule that you know. The index rule corresponding to this is that if you've got a to the power of x times a to the power of y, then that is a to the power of x plus y. So it's a similar rule to the one you've got from index, and you can have any base down here so long as they are the same base. You can't start changing. So if you had log to base 3 of x and log to base 2 of y, you couldn't use this rule to join them together. You've also got log of x over y is log to base a of x minus log to base a of y. So that's similar to the rule that you'll probably remember from GCSE, that a to the x over a to the y is a to the x minus y. So they're very similar to the way that indices behave, because obviously they're actually very similar to indices. It's just the other way around. So instead of having x to the 6, 6 to the x. So really, really similar things going on with indices and with logs. It's just a case of learning a new way of thinking about it, a new way of writing it the other way around. So I've got those two rules, and the other rule that is everybody's favourite is that if you've got a power, you can turn it into a multiple. Like that, you can just pull it down the front. So things to be careful of, mainly with this one, is that this power applies to all of the things that are being logged. So here, if you've got a 3, it goes up and everything here gets cubed, everything. So for example, 3 log 2x is not log 2x cubed. The 3 comes up here, but it doesn't only cube the x, it cubes everything. So it cubes everything that's being logged here. So it's actually 2x cubed, not 2x cubed, which is 8x cubed. So that's one to be careful of. And that's, oh, the other thing to be careful of is that there's no numbers here in the rules. So if you had a 3 here, or a 2 or something, then you'd have to move it and make it a power before you applied that rule. You can't apply this rule if there's any numbers at the front. So this one as well, you've got to make sure there's no numbers at the front. If there are numbers, move them up, make them powers, then use the rule to combine the logs together. So the only other thing to mention is the change of base. So a few people have been asking about that. So if you've got a log and you've got base 7 or something of x, and you need it to be base 2, I don't know why, you might need it for the equation or something. It might be that you've got something like this, and this is a 7 and this is a 2, and you need them to match up so that you can apply this rule. Or similarly, like here, you need them to match up so you can apply this rule. If you've got that situation, it's really easy to change your base. You just draw a fraction like that, and you write log on the top and you write log on the bottom, and you choose your new base. So if I want base 2, then I choose base 2 for there and base 2 for there. And then your x, the thing you were taking the log of, that goes on the top. The big thing here, that goes on the top. And the 7, the old base, that goes on the bottom. So it's really, really easy. Really common thing is if we maybe want to change the base here to a 3, then we'd have log to base 3 on the top, log to base 3 on the bottom, and the 3, the big thing here, goes on the top, and the x goes on the bottom, and we have log to base 3 of 3, which you'll remember is log to base 3 of 3, log to base a of a is always 1, doesn't matter what a is. If these two are the same, it will be 1. So this is 1 on the top, and log to base 3 of x on the bottom. So that's all the actual rules you need to know. We've got 4 of them. Got this rule here, which is about the sum here and the product. You've got this second rule here, which is about the difference and the quotient there. And this third rule here, which is about the power becoming a multiple down the front. And then the only other thing that you need to learn is how to change the base of a log, which is fairly simple. So long as you've got those 4 actual facts written down, and you know what a log actually is, and you understand that it's the opposite of doing, log to base 6 is the opposite of doing 6 to the power of, and log to base 7 is the opposite of doing 7 to the power of, then you should be able to use logs to solve equations. You should be able to use these things to simplify logs, and use these rules to simplify logs. And that's all you actually have to know, but I know some equations get a bit tricky, so what I'll do in another video is do some examples of exam questions and show you the sorts of thing that you could be asked to do.